Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to solve exercise 1.2 of the chapter Real Numbers. So before starting with exercise 1.2 I will do a quick recap of the rational number and their properties, as well as I am going to solve few example sums also, and then I am going to start with the exercise 1.2 and I am going to give the detailed solution of exercise 1.2. So let's begin the class. So we have already studied a number is a rational if it can be expressed in the form of P by Q, where P and Q are integers and Q should not be equal to 0. This we have already seen, right? From grade 7 we are studying rational number, and this is the basic definition of rational number, that it can be expressed in the form of P by Q, where P and Q are integers and Q should not be equal to 0. Even if you take a number 2, this is also a rational number because 2 can also be written as 2 by 1. So it is in the form of P by Q and my Q is not equal to 0. In fact, 0 is also a rational number because 0 also I can write it as 0 by 1 or 0 by 2, isn't it? So this is also in the form of P by Q and my Q is not equal to 0. So this is the basic about the rational number. Now, here P and Q should not have any common factor other than 1. Okay, because we always represent a rational number in the standard form. In the standard form means the P and Q should not have any common factor other than 1. So it means if they do not have any common factor other than 1, it means P and Q are the co-prime numbers. Okay, so let's quickly recap what is co-prime number, what is prime number, what is composite number. So prime number means the number which is having only two factors. Okay, prime number means the number which is having only two factors, and the factors will be 1 and the number itself. Let's take number 7. So 7 is a prime number because it has only two factors, 1 and the number 7. Next is what is composite number. So composite number means composite number means the number which is having more than two factors. Suppose I have taken 4. The factors of 4 are 1, 2 and 4. So here it has got more than two factors, so it is a composite number. Next, what is co-prime number? So two numbers we can say it is a co-prime if the common factor is 1. Suppose I have taken a number 2 and I have taken a number 9. The factors of 2 are 1 comma 2, isn't it? 2 is a prime number, it has only two factors. And the factors of 9 is 1, 3 and 9. And if you see the common factor is only 1. It means 2 and 9 are the co-prime number. So I hope now your basic is clear. What is prime number, what is composite number, what is co-prime number. Let me do a quick recap again. Prime number means the number which is having only two factors. Okay, I have given one example. The number is 7. Okay, but there are infinite prime numbers. Okay, 2 is a prime number, 3 is a prime number, 5 is a prime number, 11 is a prime number. Next is composite number, the number which is having more than two factors. Suppose I have taken here 4. Now the factors of 4 are 1, 2 and 4. It has got more than two factors, so it is a composite number. We can take 9. The factors of 9 are 1, 3 and 9. So again it is a composite number. Next is co-prime number. We can say two numbers are co-prime if the common factor is 1. So I have taken a number 2. The factors of 2 is 1 and 2. I have taken another number 9 and the factors are 1, 3 and 9. And I can see the common factor is 1. Common factor means the factor which is present in both the numbers, and that is 1. So they are co-prime numbers. So hope it is clear now what is rational number, what is prime number, what is composite number, what is co-prime number. Hope it is clear, right? Now there is a theorem. It tells that if P divides A square, then P divides A, where A is a positive integer. Okay. Now here your P is a prime number. The P is a prime number. Okay. If P is a prime number and if P divides A square, then P will divide A also. Now let's take one example. Now this theorem we are going to use it in exercise 1.2. So I'm going to explain it now. Okay, let's take one example. So I've taken a number a, which is 8, and a prime number p, which is 2. And according to this theorem, it tells that if p divides a square, it means if 2 divides the square of 8. What is the square of 8? Square of 8 is 64. Isn't it? 8 square is 64. So 2 will divide 64, isn't it? Because it's an even number, it will come in the table of 2. So it says that if prime number p divides square of a, then this will divide a also. Now here your a is what? A, 8, and your p is what? 2. If 2 divides 64, then 2 will divide 8 also. Yes, it is true. 2 is dividing 64 also, 2 is dividing 8 also, isn't it? So it is correct. So this theorem you should remember that if p is a prime number such that if it divides a square, then it will divide a also, where a is any positive integer. Clear? Now I'm going to use this theorem while solving the questions. Now moving to this, I have taken one example question from the NCERT textbook, and it shows you have to show that root 2 is irrational. Now first of all, what is an irrational number? So we already know that the number which is non-terminating as well as non-repeating, we call those number as irrational number. And we know that the value of root 2 we already found, right? In grade 9 we have already studied. The value of root 2 is 1.414213 and so on. So you can see root 2, the value of root 2 is non-terminating as well as non-repeating. So we already know that root 2 is irrational. Now I'm going to prove this again using some different method. Okay, by taking some assumption. So here I'm assuming that my root 2 is a rational number. So if it is a rational number, then I can write in the form of p by q, where q is not equal to 0 and p and q should not have a common factor except 1. It means p and q are co-prime number. So I have taken root 2 as a by b, where a and b are co-prime. Just now I have given the definition of rational number, right? You can write in the form of p by q, q should not be equal to 0 and the common factor of p and q should be only 1. It means they are co-prime number. Now I'm going to cross multiply. So b will get multiplied with root 2 and it will be b root 2 equal to a. Now I'm going to square on both the sides. So if I square on both the sides, then what will happen? I'm going to exchange LHS and RHS. So I'm rewriting it a equal to b root 2. Now I'm going to square it. So a whole square equal to b root 2 whole square. So a square will be a square only, and b root 2 I can write it at twice. And if you see from here, b into b will give you b square and root 2 into 2, root 2 will give you 2. So from here I can rewrite as a square equal to 2 into b square. So from here it is clear that a square is a multiple of 2. It means this 2 will divide a square, isn't it? This means that 2 will divide a square, and just now we have seen a theorem. If p is a prime number such that p divides a square, then p will divide a also, isn't it? And here you can see your 2 is a prime number. So if 2 will divide a square, then 2 will divide a also. It means this a is a multiple of 2. Clear? Let's take one example. When I am telling 2 divides 8. 2 divides 8. What does it mean? It means 8 is a multiple of 2, and you can see that 2 into 4 is equal to 8. Then only 8 is getting divided by 2. Here also it is written 2 divides a. It means a is a multiple of 2. So I can write it as a equal to 2 into c. Why 2 into c? I don't know for which multiple it is. So I have taken for any integer c, this a will be multiple of 2. Clear? Now next what I am going to do, I am going to substitute this value a equal to 2 into c over here, and I am assuming it as 1. Okay, so let's substitute the value. So a square is equal to 2b square from first it is. Now I'm going to put the value of a as 2c. So it will become 2c whole square equal to 2b square, isn't it? And 2c whole square means it will give me 4c square equal to 2b square. And from here, if I get the value of b square, it will give me 4c square divided by 2, and 2 times 2 is 4, which will give me 2c square, right? Now from here, so again from here I can say that this b square is a multiple of 2, isn't it? Because b square is 2 into c square. B square is 2 into c square. It means b square is a multiple of 2. So again I can see from here, this means 2 will divide b square. So it will divide b also. Again that theorem, please try to recall. It tells that if a prime number p divides a square, then the prime number will divide a also. So here your prime number is 2, isn't it? And the number is b. So if 2 divides b square, so 2 will divide b also. So from here what we can see that a and b have 2 also as a common factor. Here I have seen that a is a multiple of 2. Here I am seeing that b is also a multiple of 2, isn't it? So from here we can say that a and b is having one more common factor, 2. So it means a and b are not a co-prime number, isn't it? Here I have written 2 will divide a also. Here I have written 2 will divide b also. What does it mean? It means a and b is having 2 as a common factor. Then our assumption becomes wrong that a and b is a co-prime number, because a co-prime number will have only 1 as a common factor. But here I am getting 2 also as a common factor. It means the number is having more than 2 factor, isn't it? So this contradicts our assumption that A and B have no common factor other than 1. And why it happens? This contradiction arises because of our incorrect assumption that root 2 is rational. So it means root 2 is irrational number. Okay. So this is the another way of proving that root 2 is irrational. I know it is little theoretical, but this is the another method to show that root 2 is irrational. So this is the example question which I have taken from the NCERT textbook. Now, same way you can prove that root 3 is irrational, root 5 is irrational using the same steps. That we will see it little later, because it is those type of questions are there in exercise also. Okay. So just now we have seen that root 2 is an irrational number. Now, same way we can prove that root 3 as well as root 5 is also an irrational number. And we already know the value of root 3 is 1.732050 and so on. Same way root 5 value is 2.236067 and so on. So they are irrational number. The another method which I have shown for root 2, same way we can show that root 3 and root 5 is also an irrational number. Now let's recall some of the properties of a rational number, because we are going to use this property while solving the questions. The first property is the sum of two or more rational number is always a rational number. So let's take any two rational number. I have taken 1 by 2 and 5 by 2. If I'm going to add it, as the denominator is same, so I have to just add the numerator. So 1 plus 5 by 2, which will give me 6 by 2. And if I reduce it, 6 by 2 is 3. Now 3 is also a rational number because I can write in the form of 3 by 1, isn't it? So if you add two rational number, their sum will also be a rational number. Second thing, the difference of two or more rational number is always a rational number. So if I take any two rational number again, same way I've taken the same example, 5 by 2 minus 1 by 2. If I subtract, what I will get? 5 minus 1 by 2, which will give me 4 by 2, and it is further written as 2 by 1. So if I subtract two rational number, again I am getting a rational number. Now in any way you subtract, okay, either you do a minus b, if you take a as 5 by 2 and b as 1 by 2. Either you subtract a minus b or b minus a. In both the ways, the result which you will get, that will be a rational number. The product of two or more rational number is always a rational number. So if I take two rational number, 5 by 2 and 3 by 2. And if I multiply, I am getting 15 by 4, which is again a rational number, right? And the last one, the division of a rational number by a non-zero rational number. Suppose I have taken 5 by 2 divided by 3 by 2. See, the number which are using for division, that should be a non-zero. That should not be 0. Apart from 0, you can take any number. Because if you divide any number by 0, it is undefined. We already know, right? A divided by 0 is undefined. That's why it says that you have to divide by any non-zero rational number. So if I divide it, division change to multiplication. Reciprocal of 3 by 2 is 2 by 3. So 2 and 2 cancel and I am getting 5 by 3. Okay. So from here you can see that in if you add two rational number or you subtract two rational number or you multiply or you divide a rational number by a non-zero rational number, the result is always a rational number. Now I'm going to use these properties in my when I will be solving the questions. That's why I'm explaining it in detail. Okay. So you have to again recall the theorem which I have said that if P is a prime number such that P divides A square, then P will divide A also, right? That theorem you should always remember and these properties of the rational number. Now using these two things only, I am going to solve the exercise 1.2 questions. Now this is one more example question. Show that 5 minus root 3 is irrational. So again, I am going to solve this by taking some assumption. Okay, so I am assuming that let 5 minus root 3 is a rational number. Now if it is a rational number, then I have to represent in the form of P by Q. So here I have taken A by B, where A and B are co-prime and P is not equal to 0. Okay. Now from here, if I transpose A by B to LHS, okay, this I transpose to LHS and root 3 if I transpose to RHS. So it will become 5 minus A by B equal to root 3, isn't it? Now we already know that A by B is a rational number, isn't it? And 5 also I can write it as 5 by 1, right? 5 by 1 minus A by B equal to root 3. Now root 3 A by B I have already assumed it is a rational number. 5 by 1 is also a rational number. So from here we have seen the property, right? The difference of two rational number is always a rational number. So from here I can say that since A by B is a rational, so 5 minus A by B is also rational. And 5 minus A by B, the value is equal to root 3, isn't it? Here I have got, right? Root 3 value is equal to 5 minus A by B. So if this complete is a rational number, so I can say that root 3 is also a rational number, isn't it? But what we know, root 3 is not a rational number. Root 3 is irrational number, isn't it? So this contradicts the fact that root 3 is irrational. And why this contradiction came? Because of our wrong assumption that 5 minus root 3 is a rational. So from here we can say that 5 minus root 3 is a irrational number. Okay, so these type of questions always we have to solve using this contradiction method only. Clear? Now moving to the next question, we are going to start with the exercise questions now. Now exercise 1.2 question number 1. Prove that root 5 is irrational. So first of all, I'll assume that root 5 is a rational number, like how we were solving the previous question. And if it is a rational number, I can write in the form of P by Q. So here I've written A by B, where A and B are co-prime number and this B should not be equal to 0. Clear? Now cross multiply. So if I cross multiply, B will get multiplied with root 5 and we will get B root 5 equal to A. Next, squaring on both the sides. So if I square on both the side, what will happen? I am rewriting it A equal to B root 5. Now square it. So it will be A square equal to B root 5 whole square. And B root 5 whole square means I can write it B root 5 into B root 5. So from here I will get A square as B into B, B square and root 5 into root 5, 5. which further I can write as a square is equal to 5 into b square. So from here I can say that a square is a multiple of 5, isn't it? A square is a multiple of 5. Then only I have written 5 into b square. So it means 5 will divide a square, isn't it? And if 5 will divide a square, so 5 will divide a also. Try to recall the theorem. Here 5 is a prime number. So if prime number divides a square, then this prime number will divide a also. And I'm assuming this as 1. So if 5 divides a, it means my a is a multiple of 5. Then only 5 will divide a, right? So from here, I can write that a equal to 5 into c. C can take any value. It can be integer. Okay. So now I am going to substitute this value of a equal to 5 into c in first equation. So when I substitute the value a as 5 into c means 5c. So it will become 5c square is equal to 5b square. Isn't it? Where you have substituted, please see here. A square into equal to 5 into b square. And I am substituting a as 5c. So 5c whole square equal to 5b square. Now 5 square is 25. C square equal to 5b square. So from here, if you get the value of b square, you have to transpose 5 to the other side. So it will become 25c square by 5. And 5 times 5 is 25. So here you will get 5c square. So the value of b square is 5c square. And again you can see from here that b square is a multiple of 5, isn't it? So again I can say that it means 5 will divide b square because it is a multiple. So if 5 divides b square and 5 is a prime number, it means 5 will divide b also. So I have assumed in the beginning that it is a rational number and a and b will be a co-prime number. But here I can see a has got one factor 5 also and b has got one factor 5 also, isn't it? So from here I can say that a and b have at least 5 as a common factor. So if one more factor it will get, it means a and b are not co-prime number now, isn't it? Because it has got more than two factors. So this contradicts our assumption that a and b have no common factor other than 1. So, and why this contradiction has come? Because of our incorrect assumption that root 5 is rational. So from here we can say that root 5 is irrational number. Hope it is clear to everyone. Now I'm moving to another question. Question number 2. Prove that 3 plus 2 root 5 is irrational. So to solve this question also, again I'm going to assume that 3 plus 2 root 5 is a rational number. So if it is a rational number, we can write in the form of p by q such that p and q are co-prime number and q should not be equal to 0. So here I have taken 3 plus 2 root 5 as a by b, where a and b are co-prime and b is not equal to 0. Now from here I am going to transpose 3 to the RHS. So I will get 2 root 5 is equal to a by b minus 3. Okay. And then what will be the value of root 5? I have to transpose 2 to the other side. So this multiplication will become division, isn't it? So a by b minus 3. Further I can write it as I am multiplying 1 by 2 with a by b and with 3. So it will become a by 2b minus 3 by 2. Now from here, we already know that a by b is a rational number. So it means a by 2b is also a rational number. And 3 by 2 is also a rational number, right? So the difference of two rational number is again a rational number. That's what I've written. A by b is rational. So a by 2b will also be rational. And if you subtract something from a rational number, that is also a rational number. So from here, I can say that my root 5 is a rational number because this complete is a rational number and this is equal to root 5. But what we know, root 5 is not a rational number. It is an irrational number. This contradicts our assumption, isn't it, that root 5 is irrational. This contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational. That's why 3 plus 2 root 5 is irrational number. Okay, so this is a very simple one, and we will move to question 3. There also we are going to solve it like this only. Okay, so just you have to recall two theorems. The first one is only one theorem actually, and the rest is the properties of rational number. You have to just recall always the theorem which says that if p is a prime number and if p divides a square, then p will divide a also. Okay, that one theorem. And the second, the properties of rational number. Like if you add two rational number, the sum is a rational number. If you subtract two rational number in any order, then also it will be a rational number. The product of two rational number is a rational number. And if you divide a rational number with a non-zero rational number, the quotient you will get, that is also a rational number. So you have to remember these things. And some basic concept like what is rational number, what is irrational number, what is a prime number, what is a co-prime number, what is a composite number, isn't it? So in chapter 1, just you have to remember these things only. Now moving to next question. Question 3, first one. Prove that the following are irrationals. The first question is 1 by root 2. So here also I am going to assume that my 1 by root 2 is a rational number. And if it is a rational number, I can write it in the form of a by b, where a and b are co-prime and b is not equal to 0. Now from here, if I cross multiply, I will get a into root 2 is equal to b into 1, which is b, isn't it? And root 2 will be, I am transposing a from here to RHS, so multiplication will change to division, b by a. Now a by b is a rational number, so the reciprocal of that b by a is also a rational, isn't it? If you take a rational number 2 by 3, then reciprocal of 2 by 3 is 3 by 2. 3 by 2 is also a rational number, isn't it? So if b by a is also a rational, then we can say that root 2 is also a rational number. But what we know, root 2 is not a rational, it is an irrational number. So this is a contradiction, right? And why this contradiction arises? Because of our incorrect assumption that 1 by root 2 is a rational number. So from here, we can say that 1 by root 2 is irrational. Clear? So I hope now it will be very much easy for you to solve these type of questions, because I have given enough example and I have given all the properties, all the definitions I have recalled again and again. So I hope now it is clear to everyone that how to solve these type of questions. So before moving to the next question, I would like to tell everyone, if you did not subscribe my channel till now, please subscribe to my channel for more helpful maths content. Okay. Now I'm going to solve each questions in detail, which is going to really help you a lot for preparing for your exam. And at the end of every chapter, I'm going to provide some important questions which has already come in CBSE exams or some pre-board exams. Okay, so please subscribe to my channel. Now moving to second part of question number 3. You have to here prove that 7 root 5 is a irrational number. So again I'm going to assume that 7 root 5 is a rational number. So if it is a rational number, I can write in the form of a by b, where a and b are co-prime and b is not equal to 0. So from here, if I have to get the value of root 5, I have to transpose 7 to the other side. So it will become, multiplication will become division. So a by b divided by 7. And a by b, it is 7 by 1, division change to multiplication. So it will become a by 7b. So from here I can write root 5 value is a by 7b. Okay. Now we already know that a by b is a rational number, isn't it? A by b is a rational number. And what you have done, you have multiplied 1 by 7 in that. So again, we know that the product of two rational number is a rational number. So it means a by 7b is also a rational. And if a by 7b is rational, and that value is equal to root 5. So it means then root 5 is also a rational number. But what we know, root 5 is an irrational number, isn't it? So there is a contradiction. And this contradiction has come because of our incorrect assumption that 7 root 5 is a rational. So from here we can say that 7 root 5 is an irrational number. Clear? Now moving to the next question. Now this is the last question of this exercise. You have to prove that 6 plus root 2 is an irrational number. So again I am going to assume that 6 plus root 2 is a rational number. So it means I can write it in the form of a by b, where a and b are co-prime and b is not equal to 0. So from here, if I have to get the value of root 2, I have to transpose 6 to the other side. So addition will change to subtraction. So here a by b minus 6. 6 I can write as 6 by 1. So you can see here a by b is a rational number. 6 by 1 is also a rational number. And we know that the difference of two rational numbers is a rational number. So from here we can say that a by b minus 6 is also a rational. Then root 2 will also be a rational number, because the value of root 2 is equal to a by b minus 6, isn't it? So root 2 is also a rational number, but this contradicts the fact that root 2 is irrational, because we already know that the value of root 2 is non-terminating, non-repeating. So it cannot be a rational number. And why this contradiction arises? Because of our incorrect assumption that 6 plus root 2 is a rational number. So from here we can say that 6 plus root 2 is irrational, isn't it? So that's all for exercise 1.2. Now in my next video, I will be solving few questions which has already come in the board exam, or it is these are very important questions which has come in some pre-board exams. Okay, so stay tuned for more interesting videos, and please subscribe to my channel. That's all. Thank you.